compound events. Our essential question is, how do you calculate the probability of compound events? We have 5 new vocab words. The first one is compound event. A compound event just means 2 or more events occurring. And if those events are independent events, the outcome of the first event does not affect the outcome of the second event at all. So you could find the probability of both events happening by multiplying together your 2 individual probabilities. So the probability of A and B is just equal to the probability of A times the probability of B. The next vocab word is dependent events. That's when the outcome of the first event does affect the outcome of the second event. So the probability looks a little bit different. The probability of both A and B occurring would be found by multiplying the probability of A times the probability of B following A. So independent and dependent events. An example for you to think about, if you are flipping a coin, one event doesn't ever affect the next. So those are always independent events when you're flipping a coin, or if you're spinning a spinner, or if you're rolling dice. Now, if we're talking about cards, or a bag of marbles, or something like that, those events could be considered independent or dependent. It all depends on if you replace the first card that you've drawn, meaning you put it back in the deck, or if you keep it out. Or if you're drawing something out of a hat or out of a bag, like marbles, if you draw out a marble and you keep it out, that's going to affect the probability for the second event. So we'll have some examples a little bit later. Hopefully it will all make sense to you. The next vocab word, mutually exclusive events. These are events that cannot occur at the same time. They can't occur at the same time. So the probability of A or B happening is found by adding together their probabilities. So 2 events that can't happen at the same time. Not mutually exclusive events then would be the opposite. Those are events that can occur at the same time. So you can think of them as like a Venn diagram where there's an overlap between the 2 circles. That piece where they overlap means that those events can happen at the same time. So to find that probability, you are going to subtract the piece where they overlap. So the probability of A or B equals probability of A plus probability of B, but then you have to subtract out the piece where both of them are occurring because you don't want to count those twice. So an example there would be with a deck of cards, you could have a card that is red and a 10 at the same time. So the probability of a red card or a 10, you're going to do the probability of the red cards plus the probability of the 10, but then you have to subtract the red 10s. There are 2 of them. Okay, moving on to some examples. A bag contains these marbles, 6 black, 2 green, 9 red, 4 yellow. A marble is selected, then replaced. That means it's put back. And a second marble is selected. What type of events are these? And find each probability. Well, the key word being replaced. Because the marbles are being replaced, that means that these are independent events. Independent events. Now, to find each of the probabilities, we're going to multiply them together. So number 1, the probability of getting black, well, let's see, how many marbles we have total? 6 plus 2 plus 9 plus 4. So we've got 21 total marbles. The probability that the first one is going to be black is 6 out of 21. We replaced it, so we put it back in. The probability that the next one is yellow then is 4 out of 21. Now, before I multiply my fractions, I'm going to look at them and decide if I can do a little reducing. If I divide by 3, I get 2, and divide by 3, I get 7. I don't see any more common factors, So I multiply across and I get 8 147ths. Number 2, probability of red. So red is 9, so 9 out of 21. And then green, 2, so 2 out of 21 because we put the marble back. Reduce, divide by 3 again. I get 3/7. Divide by 3 again, and I get 1/7. So now if I multiply across, 1 times 2 is 2, 7 times 7 is 49. 2 49ths. Number 3, the probability that it is not black. Well, if there are 6 that are black and 21 total, that means that I've got 15 that are not black. So 15 out of 21. And then red, 9 out of 21 because I put the marble back. Reduce both of these. Divide by 3. And I get 5/7. Divide by 3 and I get 3/7. Multiply across, 15 49ths. And the last one, number 4, yellow, green, red. So now I've got 3 of them. So yellow, 4 out of 21. Green, 2 out of 21. And red, 9 out of 21. Reducing, divide by 3. I get 3/7. And divide by 3 again. I get 1/7. And it looks like that's all that we can reduce. So my numerator, 4 times 2 is 8. My denominator, 21 times 7 times 7 is 1,029. You can see some pretty large numbers in your fractions when you're multiplying together multiple probabilities. So compound events. Next example, just like the last one, only our key word is that it's not replaced, and we're now talking about cards. If you're not familiar with the deck of cards, we've got a little information for you. There are 13 cards of each suit. So 13 hearts, diamonds, spades, and clubs. We have 4 of each number or face card. So like 4 aces, 4 kings, 4 jacks, 4 queens, 4 of each number card. Okay, so now the first probability here. And what type of events are these? These are dependent events because a card is selected and it's not being replaced. You're keeping it out of the deck. And there are 52 total cards to begin with. Okay, so my first problem, probability of getting a 2 and then a 5. There are 4 2s out of 52 cards. I'm not putting it back. Then there are 4 4s, but there are only 51 cards left in my deck. 51 cards left in my deck. Now, if I multiply these, I'm going to get 16 for my numerator and 2,652 for my denominator. Notice I didn't reduce first on this one. You could reduce first though, or you can reduce at the end. This number is a little bit too large to fit in my calculator. Dividing them both by 4 gives me 663 and 4. And that's it. Number 2, a heart. Well, there are 13 hearts out of 52 cards in the deck, times a spade. There are 13 spades, and because I kept my first card out, there were only 51 left in the deck. I'm going to reduce this one first, because I know that 13 52nds is 1/4 of the deck. The hearts would be 1/4 of the deck. Now it's a little bit easier to multiply. 13 over 204. 13 204ths. Number 3, ace, king, queen. Ace, king, queen. There are 4 aces out of 52. There are 4 kings out of 51 cards left. And then there are 4 queens out of 50 cards left. I'm going to reduce this one ahead of time. So I like working with smaller numbers. So if I divide by 2, I'm going to get 2 and 25. If I divide by 4, I'm going to get 1 and 13. Now I'm going to multiply across. My numerator is 8, and my denominator is going to be a large number. Look at that. That's 3 cards, just getting an ace, then a king, and then a queen. Not very likely to happen. All right, number 4. Probability of getting an ace. 4 out of 52 are aces. Then the probability that the next card is not an ace. Well, the first card was an ace. And there were 4 that were aces. So that means there were 48 that were not aces. 48 that were not aces. Okay? Now my next card to be an ace, well, the first card was an ace, so I've only got 3 aces left out of the 50 cards. So this one's pretty tricky. Reduce 1/13. Reduce my next one. And let's see. I could do dividing by 3. Dividing by 3 would give me 16 and 17. And then 16 divided by 2 is 8. 50 divided by 2 is 25. So it looks like I've got 24 in my numerator. And my denominator is going to be a large number again. 5525. 5,525. Okay. Next example, a fair die is being rolled. Find each probability. So we're just rolling one. One fair die. That's it. So that means that you've got the numbers from 1 through 6 on that fair die. So the probability of getting an even number would be 2, 4, or 6. So 3 out of 6 or 1/2 are even numbers. The probability of getting a number that is at least 4. At the very least, it's 4. So it might be a 4, a 5, or a 6. 4, 5, or 6. So this one, even numbers were 2, 4, and 6. So now we're talking about 4, 5, and 6. Because at the very least, it's 4. So 3 out of 6 again, or 1/2. Number 3. Less than 3. Less than 3 means just 1 or 2. So it doesn't include your 3. So if I reduce it, I get 1/3. Number 4. A 2, then a 5. Now we're talking about 2 different things happening. There's 1 2 out of 6 numbers on the die. And then a 5 means 1 5 out of 6. So this is a compound event. This is compound event. So when the first 3, these were just one event, but the next one is compound. And then same with number 5, getting a 6 is 1/6, and then not a 6, well there's 5 numbers that are not a 6, so you have to multiply your probabilities together, 5 out of 36. Next question, are these mutually exclusive events? Yes or no? Then find each probability. So that's asking, can they happen at the same time? So yes or no, mutually exclusive. Heart or a 10. So that's not mutually exclusive because there are going to be 13 hearts and there are 4 10s, 13 hearts and 4 10s, but one of those is a 10 of hearts. One of those is a 10 of hearts. So 13 out of 52 plus 4 out of 52, but then we have to subtract that one card that is a 10 of hearts. A 10 of hearts. So 17 minus 1, 16. 16 over 52 reduces to 4/13. So 4/13 is our final answer. Next one, a 2 or a 5. A 2 or a 5. Those are mutually exclusive. There aren't any cards that are 2s and 5s at the same time. So there's 4 2s plus there's 4 5s. So 8 52nds. If we add together their probabilities, we get 2/13. Next one, spade or a club. Spade or a club. Are they mutually exclusive? Yes. So spades, 13 out of 52. Clubs, 13 out of 52. So 26 out of 52, or half of the deck, would be spade or a club. Last but not least, red card or a queen. This one is not mutually exclusive. Red cards, 26 out of 52 are red cards, plus 4 out of 52 are queens, but there are 2 cards that are red queens. 2 cards are red queens. So, 30 minus 2 is 28. 28 52nds reduces to 7/13. 7/13. You can write a summary now, and you should be able to answer all of these homework problems. Good luck.